Hello friends, in this video we are going to learn about recursion in Python. So a recursion or a recursive function is a function that calls itself. So let's see what we actually mean by that. In our previous videos we determined the factorial of a number using while loop or for loop. Now in this example, we will again find the factorial of a number, but this time we shall do it with recursion. So let's see how we can do it with recursion. So let's give the function a name fact and let the argument be n. So inside this we'll write if n double equal to 1, return 1, else return n into fact n minus 1. So that's the end of the function, and now if we call the function like this fact4 and run the cell, we'll get the expected output. Now let's see how this function is actually working. If you look carefully, you can clearly see that from the function fact we are again calling the same function fact but with a different argument, right? So this function fact is being called from this function only. So this is called a recursive function or a recursion. Okay, now let's try to understand how this function is actually working. So when you pass the value 4, formal argument n is assigned with the value 4. So when it comes inside the function, it first checks this condition, but this condition evaluates to false as 4 is not equal to 1. So it comes to the else block, and here what is the return value of the function? Currently the value of n is 4, so it will be 4 into fact3. Now tell me one thing, do we yet have the value of fact3? We don't yet have the value of fact3, right? So the function will not be able to return any value immediately, because for calculating the return value, the function needs to know the value of fact3 which has not yet been calculated. So let's try to understand this in detail through a diagram. Let this block be equivalent to the function call. So currently we are in fact4, right? So and the return value of this function is 4 into fact3, right? But currently we don't yet have the value of fact3. So this function fact3 will be called from this function fact4. So a new function call will be added at the top of this function call. So from here the control goes here. That is, a new function call fact3 is added to the stack. So again the function fact3 will not be able to return any value immediately, because for calculating the end result it needs to know the value of fact2 which it does not have yet. So again from this function fact3 the function fact2 will be called. So another function call is being stacked up. So the function fact2 is getting called from fact3. So we move to the function fact2. So again in this function the same thing will happen. The return value for this function is 2 into fact1, but we don't yet have the value of the function fact1. So the function fact2 will again not be immediately able to return any value, and for calculating the return value or the end result will have to depend on the function fact1. So from this function fact2, the function fact1 will again be called. Now when this function fact1 is getting called, let's look at an interesting thing over here. If you go to the code, currently the value of n is 1, so this condition will get satisfied. So finally, we have got a function call which does not have to depend on any further function call to return a value. So this function fact1 will directly return the value 1, right? Now, to which function will this value 1 be returned? It will be returned to its caller, right? Now, who is the caller of this function fact1? Fact2 is the caller of the function fact1. So, this return value will come here and this function call will be removed from the stack, right? So fact1 has returned its value and its value is 1. So this fact2 function is now able to calculate the end result, that is 2 into fact1, that is 2 into 1, that is equal to 2. So the end result or the return value of the function fact2 is 2. Now to whom will this function fact2 return its value? It will get returned to the caller of the function fact2, that is the function fact3. So as soon as the function fact2 has returned its value to fact3, it is done with its work, so it will also be removed from the stack. Now as the function fact3 has received the value from fact2, so it will also now be able to calculate its return value, and that will be 3 into fact2, that is 3 into 2, that is 6. So the return value of the function fact3 will be 6. So this is the return value of the function fact3. Now to whom will fact3 return this value? Fact3 will obviously again return this value to its caller fact4. So as soon as it returns its value to fact4, it will also be removed from the stack. Now fact4 receives the value returned by fact3, that is 6. So the return value of fact4 is 4 into 6, that is 24. So as the function fact4 also returns its value, which is 24, this function also gets popped off from the stack, and as we have got our desired value, that is factorial 4, that's where our program ends. So fact4 returns its value and that's where our program ends. Now that we have understood one example, let me discuss another example of recursion. There is a series called Fibonacci series which looks like this: 0, 1, 1, then 2, then 3, 5, 8, then 13, then 21, and so on. So let me give a space between the individual elements of the series so that you can clearly understand them. Okay, so what is the feature or what is the characteristic of the series? In this series, from the third term, every term is equal to the sum of the previous two terms. The third term is equal to the sum of the first and the second term, that is 0 and 1. The fourth term is equal to the sum of the previous two terms, that is the second term and the third term. Similarly, the fifth term is equal to the sum of the third and fourth term, and so on. So that's how it goes. Now if we want to code this series using recursive function, let's see how we can do that. Okay, let's write the function in a different cell. So we create a new cell, and in this cell we will write our function. That is, the name of the function will be Fib, which means the Fibonacci series, and the argument passed to the function, let's say the name of the argument is n. So what this function will return? This function will return us the nth term of the Fibonacci series. So if you call Fib4, it will return the fourth term of the Fibonacci series. If we call Fib3, it will return us the third term of the Fibonacci series, and so on. and as we know in programming, the index of the elements of any series starts from 0, right? So the very beginning term is actually called the 0th term, then the next term is called the first term or term number 1, then this term is term number 2, this term is the third term or term number 3, and so on. So if we call fib 0, it should return as 0. If we call fib 1, it should return as 1. If we call fib 3, it should return as 2. If we call fib 4, it should return as 3, and so on. So let's write our code. Okay, for the first two term, that is the 0th term and the first term, what should be the values? 0 and 1, right? So in the first if condition, that is our base condition, we will write if it is the 0th term, then return 0, and if it is the first term, that is term number 1, then return 1. For all other terms, what is the rule? For all other terms, the value of the term should be the sum of the previous two terms. That is, fib n should return fib n minus 1 plus fib n minus 2. So let's revisit our code. What have we done? If the value of n is equal to 0, that is, if the caller asks for the 0th term, will directly return 0. If the caller asks for the first term, that is term number 1, we will directly return 1. And if the caller asks for any other term, then we will return fib n minus 1 plus fib n minus 2, that is the sum of the previous two terms. So let's go back to the pictorial representation once again and let's understand this code in detail. Okay. So here let's say we call fib 3, that is we are interested in accessing the fourth term of the Fibonacci series. So fib 3 equal to fib 1 plus fib 2. Now where does this come from? Here in our code, what did we say? Fib n equal to fib n minus 1 plus fib n minus 2. Obviously, the first two conditions will not be satisfied because the value of the past argument is 3, which is neither equal to 0 nor equal to 1. So the control will directly come here and it will call these two functions, fib n minus 1 plus fib n minus 2, which is fib 2 plus fib 1. So that's what we have written here, fib 3, and the return value of this is fib 1 plus fib 2. Now when it calls fib 1, it goes here in this block and this block directly returns you the value 1. So from where do we get this? We have said if the value of the past argument is 1, then we will directly return 1. So the fib, so when we call fib 1, it will directly return us 1, right? So fib 1, the return value of fib 1 is 1, which is returned here. Now when you call fib 2 from here, it goes to this block, and from this block again, it has to call two other functions, right? Fib 0 and fib 1. Now when you call fib 0, from here it goes to this block, and this block will again directly return the value 0. Why does it return the value 0? In our first condition we mentioned that if the past argument is 0, then we will directly return 0. That is, if the value of n is 0, we will directly return 0. So that's the case here. That's why fib 0 will directly return 0. So fib 0 returns 0. To whom does it return? It returns to the function fib 2. So this value will now be replaced by 0. Now when you call fib 1, it again goes here in this block, and this function returns 1 as we have previously discussed. So these two values get replaced by 0 and 1. So what is the end result of this function? Fib2, the end result of this function is 0 plus 1, that is 1. So it will return this value to the function fib3, because from fib3 we called fib2. So fib2 will return you 0 plus 1, that is 1. So we have already got this value, fib1 is equal to 1, and now we have also got this value, fib2 equal to 1. So fib3 now returns you 1 plus 1, that is 2. Now let's call this function fib3 from our code. Print fib3. If we press Alt plus Enter, it will give you 2, right? Similarly, you can test it with other values as well. For example, let's say we call fib5. Let's copy this, paste it here, and let's call fib5, and if we run the cell, we get 5, and fib5 is the 6th term of the series. So let's verify that. 0 1 1 2 3 5. So this is the 6th term of the series, which is 5, and that's what we have got as the output. So that's how this Fibonacci function, you can write this Fibonacci function using a recursive call. Now a very important thing is that while you work with recursive functions, you always have to keep one thing in mind, is that you always have to mention a termination or base condition in your recursive function. If you don't specify any termination condition, then your recursive function will continue forever, which is completely undesired. For example, in this function, if we remove the first if condition, let's remove this else keyword as well. And if we put it like this, then let's see what will happen. When you call fact5, it will come here, and the return value, what is the return value? The return value is 4 into fact3. So fact3 will get called. So it will come here, and the return value will be 2 into fact1. Fact1 will come, and the return value will be 1 into fact0, then 0 into fact minus 1, then minus 1 into fact minus 2, and it will continue like this forever because you haven't specified any termination condition. So a termination condition is a must in a recursive function, because we have to stop somewhere, right? We cannot let our recursive function endlessly call other functions. So we cannot let that happen. That's why a termination condition or a base condition is a must in a recursive function. Okay, let me show you when you remove the base condition or termination condition, what actually happens. If we run the cell, you can see it is running forever. And let's wait for some time, and you can see here the error message, recursion error, maximum recursion depth exceeded, which means your function has kept on calling itself endlessly, and a huge number of function calls have been stacked up, and the number of function calls in the stack has exceeded the maximum permissible limit. Let's revert back our code. And if we again run the cell, it runs completely fine. In case of such infinite recursion, as the number of function calls in the stack is huge, it occupies a huge amount of memory space, which can lead your application to crash and your system to hang. So to avoid this, Python provides you with a function called set recursion limit, which is present in the sys module. This enables you to limit the maximum depth of the stack, that is the maximum number of function calls present in the stack. So let's use that function. First of all, let's import the module in which the function is present, and the module is sys module. Now let's see what is the current maximum depth of the stack. That is, what is the current limit of the stack, and we can see that using sys dot. Now if you press tab, it will give you IntelliSense, and now if you write the first few words set recursion, you can see it gives you the suggestion set recursion limit. Okay, instead of set recursion limit, as we are trying to first get the current limit, so we will use get recursion limit. So if we print it and run the cell, it gives us 3000. So this is the current maximum depth of the stack. That is, the current stack can accommodate this number of function calls at maximum. Now let's say we want to reduce the maximum depth to 1000, then what we have to do? You have to simply use the set recursion limit function. So instead of get recursion limit, we'll now use set recursion limit. That is, we are trying to set the maximum depth, and inside this function we have to pass our desired limit, the limit that we are trying to set. So let's say we want to accommodate maximum 1000 function calls in the stack. So if we run the cell, the recursion limit has been set to 1000. Now if we again print the get recursion limit and run the cell, it will give us 1000. That is, currently the stack will accommodate maximum 1000 function calls, and if any infinite recursion is encountered, no more than 1000 function calls will be allowed. So if we again remove this termination condition, and run this cell, it will again go to an infinite recursion, but this time you could see in much less amount of time it raised the error because it accommodated only 1000 function calls this time. So friends, that's it for this video. I have given some exercise problems. Please try to solve these problems, and if you get stuck with any of them, that is completely fine because you are completely new to this concept, and I will come up with the solution of each of these problems. So don't worry about this at all. If you want, if you can let me know the answer of first two questions in the comment section. So if you have liked my video, please subscribe to my channel so that you are notified whenever I upload more Python and data science related video. And please don't forget to like and share my videos so that it reaches a greater audience and they also get benefited from it. Thanks a lot for watching.